Earthquake update, Mr. Daniel Roden.
Sorry, that's a little odd. Good morning. Drew, is Dr. Taylor on? I have a few comments that I'll make. I'm going to try to keep my comments short out of respect for Dr. Taylor's time. But we all know we had a few more aftershocks the other day. I think on the 3rd we had a couple, a 2.2 and a 2.6. And then on the 8th, a 1.8. So interestingly enough, the 3rd, the day that we had the 2 aftershocks, was the day that I approached the county manager and the chairman about rescinding our state of emergency. So we did that, and then that night, I guess God has an interesting sense of humor. He decided we should have a couple more. So, but at any rate, we're no longer under state of emergency because of the earthquake. Should the need arise, we can always reinstitute another one. But that brings our total up to 302 seismic events now, all told. And a little update to where we're at with recovery. The demolition project on a few of the homes on Deer Haven Road and Little River Drive is about to begin. The bid packets for that demolition went out. The state, of course, is handling all that. I think that period closed on the 11th, and they're reviewing them, and they'll be awarding that bid next week for demolition, probably to begin end of the month or sometime early March, and then rebuilding. So if you guys have any questions for me, I'll go ahead and take those so I can step aside for Dr. Taylor.
How many total houses they taking down?
It's a moving target right now. Like I said, I know we're going to start with 4. We'll probably be in the 8 to 10 range realistically. Some of the homes really are in really poor shape, but a bigger home, they've told me if it's a 3,000 square foot home, it's not very cost effective to take that down and rebuild it versus perhaps repairing it. So there's some of those discussions going on too.
Anybody else have any questions?
I'm going to yield the floor to Dr. Kenneth Taylor, the state geologist. I think you guys asked for some information on fault lines and seismic events and how they measure it and all that stuff, and there's no one in the state that's any more qualified to talk that than Dr. Kenneth Taylor. So I yield.
Thank you.
Commissioners, thank you for the opportunity to brief you about this. I have a small, short presentation. If that would be okay with you, we could switch to the presentation and share the screen. Is that all right, sirs?
Yes.
You gotta let us have the screen.
Control. We need control of the screen, please.
We need control of the screen.
Try it again. Okay.
Okay.
Click that
Okay, got
and
it.
then share.
I don't feel so bad.
All right. Can you see the PowerPoint presentation now?
Yes.
There.
Okay, excellent. This is basically a presentation I did at the Emergency Management Association. I wanted y'all to sort of understand that a magnitude 5.1 is not a infrequent earthquake that we have in North Carolina. Basically, I'm going to talk to you a little bit about earthquakes, tectonics, and faults. Earthquakes in the southeast and central Appalachians, the damage in Sparta, the Little River Fault in the field and drone mapping that was done, as well as the young faults that are crossing the Blue Ridge.
Down or to the right.
Okay. All right. This is a map showing the world and showing the period of time of about a 1 year period of time, showing all the magnitude 5.1s, or ones that are equivalent to the one in Sparta that occurred back in October. The idea to look at this and see is that most of those earthquakes are occurring along fault boundaries that are called tectonic plate boundaries, and this is where a lot of the earthquake activity occurs throughout the world. So it's relatively rare for a magnitude 5 to pop up in the middle of Western North Carolina. One of the things we talk about when we look at describing things, we talk about the orientation of something, and we look at its strike, its dip, and stuff like that. So I'm going to talk to you a lot of these things about what we've seen as the plane that had the failure on it. There are two steps in here. There's a lower block on a fault plane. You just see the red line there showing the fault plane. And the foot wall is like you're standing on it. That's the foot wall. And the hanging wall is what's hanging on top of it. And what happened was the earthquake was a reverse fault that caused the hanging wall to move up versus the foot wall. And this is where you saw the offset of the earthquake or of the earthquake fault at the surface in parts of Sparta and in the areas around where there was lots of damage. The Appalachian Mountains are there for a reason because of collisions, and as the time has progressed, it's been moving for over 200 million years, so stresses build up, and it happens to be on inclined planes like these faults, and you'll have an earthquake. Previous big earthquakes from inside the plate are like Charleston in 1886, magnitude 6.9 to a magnitude 7.3 for that earthquake. That caused about $160 million in today's dollars in there. There were about 60 casualties. And you see the earthquake was felt all the way up in New England, all the way up into Michigan and stuff like that from that earthquake back in 1886. Previously, we've had earthquakes in North Carolina, such as the Skylands quake in 1916. That was estimated to be a magnitude 5.2, which is roughly the same size as the one you had in Sparta. This was one where if you look there and see on the map and look to the extreme west side of the map and see where St. Louis is, the earthquake station that was located in St. Louis University, where I got my doctorate in, they actually recorded the earthquake in the Skyland earthquake back in 1916. And there it shows on there the horizontal east-west and north-south that showed the ground shaking in St. Louis being recorded from the earthquake on that other end of the countryside. So that's 775 kilometers, or about 470 miles away from where the earthquake occurred in North Carolina. Previous earthquakes in the east, there was the Mineral Virginia earthquake. For Mineral Virginia, you had a huge amount of earthquake reports for that magnitude 5.8. And then you look at there and see in California where it's a much smaller area. The eastern United States, that being east of the Rockies, is old and cold, and therefore it carries the seismic waves further and longer. The ones in California, the ground or the earth is warm and it's brittle, and it basically does not allow the earthquake waves to travel as far. So for two earthquakes of almost the exact same size, a 5.8 in Virginia and a 6.0 in California, you see the felt area for it was 10 or more times larger. For Sparta, the USGS got 140,000 responses. One of them was my daughter. She lives in Ashe County. She said it was feeling like a truck was driving underneath the house. There were no fatalities or serious injuries. There were 5 foreshocks, and there were about 200 plus aftershocks. The one most recently probably comes up to be about 250. Now, there are active seismic zones around Sparta. One of them is the Central Virginia seismic zone. You see to the upper left. You also see the Giles County seismic zone, which might be partially connected to what caused Sparta. And then you have the Eastern Tennessee seismic zone. All the green dots are earthquake locations over a period of time. And this came from our colleagues up in Virginia. So when you look at that and see that one of the key things that picked up on it is the first indication of an actual fault rupture at the surface. This was a Little River fault that occurred from the earthquake, and it basically was about 2.5 kilometers, or about 1.5 miles in length. and that was where the actual ground broke. It actually broke the surface. The star there shows the estimated location for the magnitude 5.1, but you're looking at the surface expression of it. When you look at it in depth, it would be down below that plane and on it where the earthquake occurred. And that's why the rupture occurred like it did. There was basically 500 structures damaged, estimates with $15 million. That's from Alleghany County, as well as some of the stuff from the USGS. The Little River Fault is not a continuous break line. It's a broken in pieces and places. There will be places like, for example, along the river where you'd expect there not to be much to be seen because the earth at the surface there is very pliable and you wouldn't see a good indicator. This is an idea of showing where the area was across where there's deformation along the area. Here's some of the damage. You all have seen this umpteen times before. I just want to indicate that the number one thing seeing happening in an earthquake of this magnitude would be damage to chimneys and other kinds of tall masonry, unreinforced masonry kind of structures. Like, for example, the chimneys breaking in half, breaking fully off the building and stuff like that. A lot of the concrete block wall, there's not cement poured into the actual openings in a concrete block, so the wall is not nearly as strong as it could be. In California, of course, they require that to be fully filled with concrete and rebar included in it to make it stronger. But that's because the earthquake hazard in California is much, much greater than North Carolina. Once again, you see that stair-step pattern showing where the building failed, and that's where the fail point was. It basically started at the windows and worked their way downward to the outside. We also had rotation and slippage of tombstones and the and markers in the graves or in the cemeteries. And a big part of that was this rotation can give us an idea of how much of the motion was going up, but also how much of the motion was going side by side. These are cracks in the roads. These are also cracks that occurred due to slide related. The one that has the rock hammer on the extreme right side there shows where the slope was too steep, and that's why part of the slope slipped off, and that's not an earthquake fault. That's an actual failure due to the wall, or due to the slope partially collapsing. This was one where there was damage and an infrastructure issue. You see where the road buckled up because that's where the hanging wall reached the surface and broke along that road. That was fixed by the DOT, I think, the next day. You can also see places where the ground moved up in the area near the Scots, their company right there. This shows you an example. One of the professors there from UNC Chapel Hill shows this looking like almost 3 or 4 inches of displacement where the hanging wall rose and the foot wall stayed where it was. So you ended up having that difference in elevation. So the hanging wall is where he's standing and it went up over the foot wall. Once again, it's a reverse fault like I've shown before where the top of it moves up, the one part moves up, the hanging wall moves up, and then the foot wall moves down. This is a trench that was cut at the location and shows the actual fault itself. That's 2 of the staff from the North Carolina Geological Survey there, and one of the folks from USGS. And the biggest thing about that is that that's where we have the first ground breakage of an earthquake on the eastern United States ever. They're excavating that out right now. They dug a nice trench and they got this information from it. A lot of colleagues came in from NC State and other places to look at it to get information about it. Once again, you see the hanging wall rose up above the foot wall. You can even see crenulations here because the whole building that's a metal building actually got shrunk a little bit because they were on the fault. So that's why you see the crenulation there. Sort of interesting indication of the movement of the building and how it was compressed by the fault movement. This gives you some examples of showing that it's a very complex fault, but the key thing about it is that you can see movement along it, and that's recent movement from the actual earthquake. The plane is dipping about 75 degrees downward, and the whole thing about it is this sort of shows you that there's iron staining on there. There's a magnesium oxide coating on it, which means this fault's moved before. This gives an example of showing that you're talking about it being along this profile here between A and A prime and B prime there. You're talking about 10 centimeters or 12 centimeters of actual motion that basically stepped up between those. So it really clearly indicates where the movement of the fault occurred. And you see, once again, the hanging wall, the HW, rode up over the foot wall. Once again, you see the hanging wall riding up on the foot wall here where the water line was broken, but also the buckled road. This is fixed up. This was a day later or next day, and DOT had already fixed the problem already, and that was the end of it. There was a lot of places where the staff went out and trenched to look and see things. There were some places where the soil is very soft, and therefore you didn't really see any example of there being offset. You can sort of see where the little line you see there in the information from the drone, you can see sort of that line going between the hanging wall and the foot wall on that, and showing the orientation of the rupture. Here's some more dramatic places where you can see the rupture very, very easily there, where the hanging wall rode up over the foot wall, and this is in the woods west of River Edge Road. About 20 centimeters of vertical offset was occurred. Okay. The seismicity around Sparta this is the earthquake activity that's been showing that was collected. The folks from the University of Memphis, the Center for Earthquake Research and Information, put a station out there, and several stations out there in Sparta after the first 2 or 3 aftershocks or foreshocks had occurred, and they actually recorded the magnitude 5.1 right there at the site, and it's very dramatic to see where the records basically show movement occurring on a period of about 3 to 4 minutes. This gives you an idea of looking at and seeing the fault plane. This is the estimated fault plane, and then that's where the magnitude 5.1 is located. It's not on the plane, but I have a feeling that when they relocate all of these earthquakes together as an ensemble, it would get to line up or very close to line up where that fault plane is. And that's really what was the triggering event that started the earthquake sequence. So one of the key things about it as we look at there and see is that this is one of the fault planes that when you have a focal mechanism like this, it gives you an idea of how the earthquake actually broke. And it gives you 2 possible solutions. And the one that's marked in red there is probably the best one for the plane that actually broke in this earthquake. There will probably be many graduate students and such that will be working on this and doing papers on this in the foreseeable future. North Carolina Geological Survey, we're sort of like, we deal with it at the present, and then that's it. Let someone else finish off that with other information. Okay. There are other structures that go across this area, so it's not the only place we could have earthquakes in the immediate future. but we don't typically have earthquakes of magnitude 5 except for on the order of hundreds of years apart. There's the Sparta fault and all the earthquakes associated with the Sparta earthquake. And then you see the Boone fault and seeing there's other earthquakes associated with that. One of the staff that works for the North Carolina Geological Survey right now, Jesse Hill, he finished his doctorate at University of North Carolina at Chapel Hill with Kevin Stewart. Kevin Stewart, this is one of the things they were very fascinated about, finding this fault that they didn't know that existed before. The Boone Fault really is a northwest striking fault, and it cuts through all kind of things. The key thing about it is that this is one of those areas where you have to think about it being, could this break in some time in the future? Yes. Did it break a long time ago? We don't know. So in capping up here, this is the first documented surface rupture of a modern fault in the southeast United States. The south-southeast striking thing was basically activated by the magnitude 5.1. The reverse faulting dips about 20 to 45 degrees to the southwest, and it's about 2.5 kilometers of on echelon fault strands there. So in terms of looking at it for being, one of the key things I want the commissioners to understand is, could there be a magnitude 4 tomorrow? Maybe. Could there be a magnitude 2 tomorrow? Probably. Could it be a magnitude 1? Maybe. But the key thing comes down to is we're not expecting to have an earthquake anywhere near the size of the magnitude earthquake that occurred. Each step on the Richter scale from a magnitude 5.1 down to a magnitude 4.1 is a 30 times difference. So it takes 30 magnitude 4.1s to equal the energy in a magnitude 5.1. So when you look and see there's been small earthquakes around here, the magnitude 2 and 3s and stuff like that, you're talking about them being 900 times smaller than the earthquake of the magnitude 5.1. But if you have fragile buildings that have been already damaged by the 5.1, there would be a possibility of having more damages in those buildings because they've already been critically broken. Are there any questions?
Sir, Commissioner Irwin's got a question here. Bobby?
Thank you, Dr. Taylor, for the information. My question is, do you think that there needs to be any change in the building codes for this region?
The key thing comes down to it is the building codes are an engineer's domain, not a seismologist's domain. But as a seismologist, I would indicate to y'all that had some of those concrete block buildings that had foundations, or that everything below the living floors were open block that did not have any cement in them. It would be nice to put that where it would give more strength to that foundation and such. There might not have been that much damages or that extensive damage on that. One of the biggest things I look at and see is, as a seismologist, I've chased earthquakes all over the country, and a lot of times when you arrive there and see, for example, an entire ceiling tile system at a school. I mean, the entire school. When I went to Ashtabula to a magnitude 5.2 earthquake, every single piece of the ceiling tile, all of it failed. All of it failed at one time. And all of it failed because of a magnitude 5.2 earthquake. Now, that causes a great deal of impact to a school. Those schools had to be cleaned out and cleaned and fixed up and stuff like that. But one of the critical parts about it is putting wires between those panels to keep more strength and stuff like that. That's sort of the retrofit that I did in North Carolina, in the western part of the state, when I first came on as the earthquake planner. I started with emergency management, North Carolina Emergency Management, back in 1994, and I was put in charge of retrofitting schools for decrease their earthquake hazard. And a lot of that was getting the stuff done to make sure stuff was bolted up, bolted down, but also that the ceiling tile system was completely and totally taken care of, so you wouldn't have to worry about that falling on the children.
Thank you.
Anyone have any further questions?
I have a question.
Michelle?
And that was very informative, and I really appreciate that. My question to you is, I know you don't have a crystal ball or anything, but do you expect this to calm down? What should we look for in the future?
In the future, I would look in there and see that when our colleagues from Memphis State University had their seismic network out, they were recording earthquakes that were as small as -1. That would be, that's from, on the Richter scale. Those won't even be felt by anybody. They'll only be recorded by instruments because it's just too small. I'm sure there are earthquakes happening now, but it's a matter of because they have moved back to Memphis and picked up the network there. We won't see all the little teeny ones that are happening, but the ones that are basically the magnitude 2.5 and greater there, you'd know it happened because you felt it. So I would look at there and see that my thing would be the number of earthquakes and the frequency of the earthquakes will diminish over time as they did after the magnitude 5.1. And over time, it will come back to be where, okay, there's not a real problem with that. But I also look at there and see, is it as your EM director said, it's always good to look at some of these houses again sometimes and see if there's been additional damages that cause some other critical part to get broken again or broken worse.
Thank you.
Any other questions? John?
No.
Sir, I believe you answered a lot of questions we had with your program you presented this morning. It's been very informative, and we certainly appreciate you taking your time out to join us today.
I thank you for the opportunity, sir.
Thank you. Daniel, you have anything further?
I'm all done, unless you have questions for me.
Anybody got any questions for Daniel?
None.
All right. Thank you, sir.
Thank you.
Thank you very much.